Hello everyone. Today, as you can see, we have a cross product that we are trying to do. And since it is, I'm going to show you a magic trick with cross products. So see if we can really have a magic trick inside a cross product. So the cross product is going to use two vectors to give us another vector. Remember the dot product, we get the two vectors and we get scalar because we get the magnitude of two vectors, and the cosine we get scalar. But for this one we get vector. So I'm just going to assign vector A is going to be 2x hat plus 3y hat, and the vector B is going to be 1x hat plus 1y hat. Then I'm going to use my protractor as a tool to determine, okay, what is this angle between these two? So I use my protractor. I cannot show you right now here, but I use my protractor and it gave me an exact value of 152 degrees as an angle. So we know that is not going to be, that's for now it's not going to really affect us, but let's see, because if you use the dot product of A and B, vector A and B, that's going to be affected, but not currently. So we're going to use these two and try to find out the cross product. So when we do the cross product, we're going to do x cross y, y cross x. Just like how algebra sometimes we cross from numerator to denominator, that's pretty much what you are doing. So from x and y hat, we are going towards the circle from 2x hat and 1y hat. So that's positive, and then we're getting the vector, the z hat. So we're going to get two z hats. And then on the other part, although this is not going to come out of the board, this is going to look inside the board because it's negative. But anyways. And then we do 3y hat cross 1x hat, and we get negative because we're going from y to x, so we're getting negative, and then we get the z hat again. So negative 3z hat. So we're going to left a vector z is negative 1z hat. Now from what is this, how can I tell you? I can already tell you that this, if I do dot product vector A, dot product vector A and vector C, I'm going to get 0. And I'm going to same thing get 0 with vector B and vector C. Now I'm going to show you why. Although there's a perpendicular, and the rule for perpendicular cross product, just like dot product, means you're going to get 0. Yeah, but cross product, we're also going to use dot product. So I'm going to actually go ahead and do that to actually prove you that, yes, this is going to give us a 0 as a dot product. So let's go ahead and do that. Now we get a vector from cross. Let's see what we can do with dots. I have only made one mistake on the last video and the last portion of this video, and that was I actually forgot to put 1 for my b vector, because b is going towards the left, so that has to be negative because we have Cartesian coordinate system, which is y x hat and then z hat coming out of the board, which we actually had z hat for C. But the thing is, it doesn't really matter if I have negative for this one, because when I do y across x hat, according to the rule that we have a cross product, I still have to get positive. So that negative is just like for proving my coordinate system is right, so I don't make a mistake on that one. But here we go with this magnitude of vector b and then vector c, and also vector a and vector c. No matter what I have, because remember, as I said it again, we had a perpendicular because z hat comes out of the board. So no matter what we put the vectors of a and b, we're going to get it perpendicular to vector c, because we're going to have a z component for that, the z hat. So you're going to get cosine of 90 for those. And remember, cosine of 90 is going to be 0. And the perpendicular rule for dot product is going to be 0. So for the cross product, so we can find out that, okay, cross product is also going to give us 0. But cross product is going to give us like the vector. Right now we're going to get, instead, right now we're going to get scalar because it's dot product. And we get all that we could from component, because we get the magnitude, remember, square root, and then square root of what? The sum of the squared components will be the magnitude, and we can get that to get magnitude and then times that by cosine of whatever angle they have to get the dot product.